Yeah, I mean, I'm like hesitating here because this thing should never be called for two constants. So there's not even a reason to this requires. But, you know, doesn't hurt to leave it in, huh? I can't think of another way than to just make a long list of every type that I have. So let's see, after the constant we get a symbol. Maybe I should make this that E2 is not allowed to be any product level type. And since that is a concept anyway, maybe we should make a new concept. Can you negate a... No. Well, okay, I could make it this a non-product level type, which then automatically also does not include a constant. Yeah, so then we got here. Let's see, find this thing. The negation of this. Let's do it right away. So much is missing still. It's the reverse, right? So that should be false. I did not define that. I only defined the second one to be a non product level type. It's kind of nonsense, and let's make this an expression. Yep. Yeah. I probably should make a different struct. Guess I'll have to call it exponentiation. Hello. Shift V 75J. Yeah. Substitute, make power T. Make exponentiation T. Which doesn't exist, of course. To find make power is something maybe. Here's make power. Two all the way at the top. Why not move that down to just before this multiplier? Make multiplication. Multiply on equals not a product. Here's a make power. Make power. So don't need this. Mm-hmm. Oh, fuck. Yeah, okay, yeah. Yeah, no, okay. Maybe, sort of. It doesn't deal with exponentiation either. Damn. There's so much less than. Does deal with it. Okay. Does deal with it. Yeah. Get multiplication. I want to say that anything is less than an exponentiation if already have that here for the product. A product is less than anything that is not a constant, a symbol, a power, or a product. Do I also have this for, say, a power? No, here, right. Power is less than anything that is not a constant, a symbol, a power, or a product. And here we have it for the symbol. Symbol is less than anything that is not a constant, a symbol, or a product. Okay, let's say an exponentiation is less than a multiplication. Is an exponentiation ever less than another exponentiation? Yeah, well, we want ordering. Can they be combined if they have a different exponent? No, not seriously. They only need to have the same base to... I might as well add an ordering for the for two exponentiations. So one exponentiation is less than another exponentiation if the base is less, or if the base is equal, that is, it's not less, but it's also not less when you switch the bases, and the exponent is less. And exponent is always less than a multiplication. So then what is left is to compare two multiplications, right? Now let's do the same thing as I did with these two sums. So this is less when the first argument of the first sum is less than the first argument of the second sum. And if they are equal, then the second pair. In other words, you can just copy this. Yeah, that's a whole different error. No evaluation for sum. Oh, actually, arc1. Sum arc1. Why not? Evaluate type name T arc1 type. Node candidate template class T requires expression. It's not fun. This is not fun. I'm not feeling like reading 2 pages of error. What is the problem here, man? Clearly, I'm trying to call evaluate with as a template argument a sum. Error no matching function for call to evaluate on the argument 1 type. A normal compiler would say which the type is then. What is that type? Well, we can see that actually it is multiplication. So what it really means is there is no evaluate when t is multiplication, or candidates, and let's look at the first candidate. Yeah, that's the only candidate is all. And this then should call that one. Multiplication type. Yep. What? This line is 37. Some matches, still that wine. Whining. Oh, I think I get it. Yeah, I get it. Jesus. Does it make me good or does it make me good? Although okay, I'll tell you what I thought that it was. This evaluate here, where t is a sum type, where the argument 1 is a multiplication, is trying to call that one. So my thought was, maybe this one isn't found because it isn't defined yet. But you would think that it just knows that this exists and knows that this exists and knows that this exists. And only after it leaves this whole file and everything is known, it will try to instantiate this function. And only then it will try to find that one, and which then should already be known. So yeah, let's try if a for declaration helps, but it would be very surprising, right? No, it clearly held. That is surprising. Well, I don't know. Let's for declare all of them then, because you never know what you encounter suddenly. No, this one is not calling evaluate, so I don't need that for declaration at this point for this one. I also don't need it for this one. This one is calling evaluate on the base type, which is, in the case of a power, always a symbol. So that calls this one. So there also nothing needed then. The product calls it on the first argument, which is always a symbol or a power, so also defined above. And the second one is the same, or it is a product, so which would be a recursive call, but I guess that will work. The sum then might have a problem, so I do need for declaration before the sum. Of these two. And then that should work. Okay, so that was this one. Something went wrong here. It's not printing a minus. Yeah, that should be easy. Let's just fix it. That's in printing multiplication. No, sorry, printing a sum. Printing of the sum that happens in symbolic. I'm only testing for a product. I guess those also hold if U2 is a multiplication then. Term negate E2. Needs parents, term print on, needs parents, and then return. Oh, the whole thing is negated, and that's the only thing that's left. Yeah, this must be correct. So I think I just gonna add here, or is multiplication E2. No, that didn't work. Still printing it like that. Let's add it to the test suite. Seven times x plus 1, do that, and then this must be a minus 1/7 times y times the same thing. That won't work. Why is that one suddenly breaking? What did I do? Oh, I changed the ordering of stuff. Because now it is this. I have to check that one. Where is that thing? This one, right? Great. It put a half up front. Of course, because yeah, this is a multiplication because it contains an exponentiation. And then a constant is smaller as well, should be on the left. And then the base is compared, so A is less than this whole thing, which is more complex, so that makes sense as well. And then they match again. This one got reordered. X times A plus B to the power 3. That's this one. Yeah. No, X comes first because it's a lonely symbol. And this one. Okay, that's the one that is wrong. So the minus here is printed. Still. Just to be 100% sure that is the. Oh, then everything's going to fill though. Oh well. I'll just have to disable everything. No. Plus exclamation mark. And then of course the next question is, do we get here? It should be, because I would think that E2 is a multiplication. Well, I think we do. But the minus is never printed, so apparently then this is not true. It's a constant less than 0, the first argument of that multiplication. No, because the multiplication is actually starting with a product. Again, so I need a kind of a recursive thingy there then. So that is a product, and that has a negative first constant. This is a product of constant with a sub times an exponentiation. Yeah. Do we need a static? Feels like you do actually, but I think I haven't done that before. I had compiled so far. But yeah, but then again, I only have a single compilation unit, right? So maybe they should all be static. Probably should all be static. Is this where I begin with my static, or shall I just not do it yet? Can make it an eval. And I cannot use an eval for a variable. So yeah, expression then. Oh, that's a difficult question. It has to be static or not. I mean, it's in a header, so 2 different compilation units would include this header and instantiate it for the same T. Maybe that's allowed because it's a template variable, and the compiler will, the linker rather, will then resolve it, saying, yeah, okay, it's I find this thing in 2 different compilation units, but it's a template, so. You know, this is the thing with templates. They live only in headers anyway. I'm gonna leave it like this. As a negative vector v is a blah blah value. Okay, that should do it. And then we have the case where the negative vector is specialization something standard true type. What is the specialization? Well, let's keep it simple. A constant, yay. Some constant, which takes 2 ints, right? But not every constant. No, 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 no. Requires that the numerator is negative, of course. So any constant with a negative numerator is indeed having a negative vector. And then I can overload the product. As a negative vector product. Well, clearly that is only the case when the first expression is a constant. And well, a negative constant. You could do requires. This just has to be a constant expression. So I gotta keep it as expression. I have to add a requires anyway. Requires, and then we can do the thing that I did here. So if the, oh wait a minute, that would be E1 then. So a product that starts with a negative constant as a negative vector. No, it just looks silly. I'm going to make it a constant type here. And I can't type. And then to fix our problem, struct as a negative vector multiplication. And I hope that the recursiveness is going to work. Cross fingers. Well, this must be an expression now. Well, it can be multiplication, I think, even. No, the first thing is not a multiplication, but it could be a product. So this is a constant or a product. Wait a minute. Can a multiplication start with a constant even? I don't know. Let's assume so. Requires, and then the recursiveness comes as a negative vector, e1. But yeah, that might use itself. So then the multiplication that starts with the multiplication. Oh, wait a minute, that's actually never happening. So it's not recursive because e1 is never a multiplication. Well, it could simply be a constant or a product. So now we have solved the problem. And then I can use here as a negative vector, e2. Oh, is it? Negate e2. Oh no, I can still do the negate, yeah. Negate. If the negate is powerful enough, it will find the constant, I hope. It's a good question actually. What happens if you negate a multiplication of a product with something? So multiplication of a product of a constant. Is that going to find the constant? Probably. Probably. You can test it out right now. That's not going to compile the first time, of course. Well, here it happens. Negate is trying to multiply. With -1. So we end up in multiply unequal of a constant -1 with that multiplication, which has a product and a constant inside of it, and that's probably apparently, I mean, not going the correct, not going the way we want. Sorry, Ahmed. Sorry, I was not looking at the chat. Dit ik kon zien wel, bla bla bla. So now you're telling me that the constant is not less than the multiplication. Dude. Compiler dude. You make no sense. Yeah, well, pretty clearly. Multiply unequal. Constant -1. And multiplication something. And that gives us the sanity check fails, so we're calling the sanity check, and that says is multiplication E2, yes, because we're multiplying -1, constant -1 with a multiply. And then that returns false apparently. So this is false. But that is not false because of less, oh wait a minute, the less multiplication. Yeah, and E1 is a constant and this is then the product. Dubious question. Wait a minute, I have to think about this. Why would that be? Why? Even if this assertion is not failing, the -1 is failing. It's not 0, it's not 1, so it's going to construct a multiplication, which is not helping at all. I think I'm going to insert the constant inside the first parameter if E2 is a multiplication. But let's first fix this one then. I suppose the problem here is that I should actually be calling is less product, or have the is less multiplication be defined the same as is less product. If they are both product types. So I don't think this is good to begin with. It should just be this. Twix. Now we have a minus 1/7. Magic. It's pure magic. Okay, so let's make the test suit whole again. Let's make the test suit great again. I want to drag something. Okay. So what happened here? Now it prints minus 1/7 here as well, of course. Probably still stuff wrong, but I'll have to wait until I run into it. I think evaluate more or less works now. Well, it already worked. I just ran into something else again that was wrong for formulation. Shall I do differentiation? Can't be that hard. So differentiation. So we need to define now. I have an evaluate and well, differentiate is like almost the same thing, except a little bit different. So header is symbolic. So we edit symbolic slash symbolic.h and I add include differentiate.h. And then I just go to symbolic because I don't want to keep typing the directory names. And then I edit evaluate because I'm going to steal stuff from there. And differentiate.h. And then we see that we need to begin with probably this. And then end with this. And then think about this. It's not called evaluate now, it's called differentiate. The thing still does take something, which is an expression. But it's not returning a double, it's returning another expression. Nobody knows what, so auto. Some type. Still more. A differentiation of a constant type. Okay, let's copy a little bit more. Power products. Let's do these first. So evaluate becomes differentiate and double becomes auto, sort of. Constant type. Well, differentiate a constant. That is going to be 0, right? So we return 0. Constant 0. Instance. Think about it. Looks okay-ish. Yeah. Probably should do a differentiate type, actually. Return a differentiate type. I thought I already had that. I mean, here. Differently. I have one that takes an argument and then calls something else. So we want to go for, yeah, well, okay. This sucks. Well, not really, but kind of. They're too different. They're different, yes, well. Let's say at the end I'm going to do this. Maybe not for declare. They're too different to really copy stuff. Okay, so this is the only function that you have. That is being called anyway. I'm calling differentiate. T is the formula. And S is the symbol that you want to differentiate. relative to the partial differentiation. And that then we do that by type. So I get the the thing. I get the thing here. The what is it? The derivative. There we are. Maybe we should call it derivative. Let's call it derivative. Derivative. So I get the derivative of t with respect to s. And then we have to return an instance of that because this stupid function wants it. And then everything above this just must be in terms of struct, or rather, yeah, a struct. So I need to define that struct. Template expression struct derivative. Might as well do not define it. And then add specializations of the derivative. Wait a minute, before I do that, no, const expression my ass. Using type name derivative type. So it's abbreviation, so I don't have to type the type name and the type all the time. This is what you use here. Oh, and I see I missed my symbol again. I'm listening to a play song. No, it's what is it? A playlist with songs. And this is a song that I picked to play during the funeral of my mother. Now I want to share it, of course. It's not true, right? It's more like always 0, unless. This is not working, of course. I have an addition. I don't have a subtraction. So I'm gonna have to do add. Exponent plus minus 1. Exponentiates and then multiply with the exponents. That should work. Going to test this. Ubiquitous. What would that be? Jeez. My denominator is negative. Why? Isn't this ridiculous? That it tells me. Oh, maybe I'm subtracting 1 from 0. No, never mind. Okay, back to the ridiculous. It's not telling me exactly where we are. I don't even see a negative something. Well, there's a negative here, but it's the numerator. So, where are we? Wait, this is nonsense. That's nonsense. Oh, positive. I'm reading like it's negative, but that means that must be larger than 0. It's equal to 0. Yep. I made this mistake more often. Minus 1 divided by 0. That's not minus 1. No match for operator, blah blah. I can't do that, yeah. I need a constant now. Is there no way that you just can add that? Of course you can add that, man. Come on. Of course I want to do this and then use an int. Let's try to add it. I think it's not working because this is not a constant expression anymore. It's going to tell me that exponent is not a constant expression. Maximum annoyance. Yeah, it isn't. It obviously isn't. That is why this will never work. Another flaw in C++. It's actually the same flaw I discovered a week ago. Flaw being annoying me horrendously. Okay, this is just not possible. I'll have to use some type instead of an int. No, it's the last one. Constant 2. constant 5. Now, after weeks and weeks of working, finally, for the first time, differentiation. Bleep. dx is 1, dy dx is 0, minus d minus x dx is 0. Whoops, that's not true. That should be minus 1. Failure. But that's because I didn't implement everything yet. That's a derivative of a negation. So I can fix that next. This is a derivative of a sum. So everything that's not implemented gives 0. Here's one that works again. The dx times x times x dx is 3 times x squared. Yes, yes, that's good. This one is just not implemented. Well, let's do the difference thingy of the negation. Probably negation, isn't it? Do I even have a negation? Negate. I have a negate, but I don't have a negation anymore, I think. Negate is just multiplying with minus 1. Multiply here, multiply with the constant. So that's actually a product. I could do product next, then that should work. Start working. Differentiate products. You see how little work this is. I did so much work on the formulas. And now we do differentiate. Top, 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 top. Easy. Okay, so now struct, take the derivative of a product. The product exists, of course, of an expression. Sorry, just one, E1 and E2. And we differentiate relative to a symbol. Template, expression, E1, expression E2, int ID. Now, it would be nice if I could immediately short circuit the fact that this product doesn't use that ID, doesn't use that symbol at all. And we can do that because the product has an ID range. So if my symbol doesn't fall in this range, then the result is 0. So it definitely has to fall inside this range. And we can get the ID range from, well, this ID range thingy here. It then has an ID range, is simply having a begin and an end. Okay. I'll use that. So at the very least requires that the product ID range dot that not even necessary. I mean, the 0 is gonna get out of it anyway. Maybe, I don't know if it's compile time faster or not if I add that, but shall I add it anyway? I don't know. Okay, begin. Let's do it. Is less than or equal ID. And ID is less than end. But anyway, the result is going to be the derivative, say the multiplication, multiply of E1 with the derivative of E2 with respect to that symbol. Plus the derivative of E1 with respect to this symbol times E2. What do you think? Does this work it? Is this correct? Why is derivative t not highlighted? So let's start with that. CTech VR. So the derivative of E2 with respect to the symbol multiplied with E1. Yeah, that's a multiply. Nope. Should have been there. Adding that one. Multiply the derivative of E1 times E2. I think this works. Yeah, now we get -1. The rest is still 0 because there's all involving sums. So next, I guess I'll do sum then. That was a product. What do we get after products? Well, sums, right? Template, something, struct, the derivative of a sum of two things with respect to this symbol. Same template parameters. Derivative of a sum is, of course, the derivative of the first thing plus the derivative of the second thing. Now you have x plus y plus 42 dx is 1, correct, correct, correct. And this one is not implemented yet because this is an exponentiation. I didn't do the exponentiation yet. Let's do exponentiation. There's only 2 left. differentiation and multiplication. The derivative of an exponentiation of some expression to the power of some exponent with respect to some symbol and that is a template expression E constant type exponent int ID for the symbol using type equals, well, that's exactly the same as power, of course. Might as well copy this, huh? Multiply exponent with an exponentiation of, well, that's not a symbol then. E to the power exponent minus 1. That's not correct. That is not correct, and I realize immediately what I stupidly did wrong. This is all nice and dandy, but I still have to multiply that with something, namely the derivative of E. Derivative of E with respect to the symbol. Where's my symbol? Here. Oh, that's disappointing. Oh my god. It did not combine the 2 and the 5. Shocking. What is going on? Why? For the rest it seems correct. Derivative of this is minus 2 times x. And then the whole thing times 5 times that to the power 4. Yep. But yeah, it should have combined these constants, of course. Yeah, nothing to do with the differentiation anyway. That should be done by the monstrosity that I wrote before this. Okay, let's think. I'm gonna add a new test, I guess, for this in symbolic. It's probably a multiply between this and that. Why would that not work? It's a product and a multiplication, I think. How is that? How can we do that easily? I could just product and yeah, must be. So we can mimic that by first creating that, which will be a product. And then creating this thing, which should be multiplication. Or I'm afraid I have to do a 2 here and parentheses around it. And then this is a 4, which I don't have, constant 4. And parentheses around that, because caret and stuff. Set up like that. And this is a constant 5. Constant 5 times y minus x to the power 2 to the power 4. All multiplied with that, see what that gives. Yay, it indeed fails. So I found another thing that it fails. It gives me this, but yeah, no, obviously that should have been minus 10 times x. It also prints a type, right? That's why I brought it here. This is a multiplication of a product of a constant minus 2 times a symbol with a multiplication of 5 times an exponentiation. Now, man. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Brilliant. Let's face it, if we start at the beginning, it is operators. It's the operator star. And operator star just calls multiply. I'll call everything calls. Instantiates, multiply, whatever. Where this E1 is something, and E2 was there was a product, I think, and that was an another multiplication. Let's have a look again. The first argument is a product. Yep, product and a multiplication. Now multiply t is just multiply, so we have to find the multiply struct that is the specialization for product with multiplication. This is a constant, so that's definitely not it. This is also not it, because is product means that E1 and E2 are both products. Should never get here then for the multiplication. This looks like the catch-all for everything else. Huh, what? How is that not ambiguous with this one? Man, I'm totally happy with seeing a bug, but I don't understand why then I have not gotten an error for this one. When I try to multiply anything with a multiplication, it should say, well, I don't know what to use, this one or that one. This is, okay, maybe you can say this is more specialized than that. Maybe that's the way, maybe that's the reason. I mean, since it did not complain, I'm gonna guess that it's going to use this one. Or I could add a requires here that E2 is not a multiplication, I guess. Well, that's what I would do if it says that it was ambiguous, but products. But this is a product again, is product. Yes, product. Not a product with a sum, two sums, that's it. So it's probably, it probably did use this one then. Where E1 is a product and multiplication is the multiplication. Then it says is less. Yeah, product should be less. Make multiplication. Okay, so make multiplication isn't working. I mean, they're different. They're not the same, like that you can combine them into a single exponentiation. Totally not the same. And the product is less than the multiplication. I mean, rather arbitrary, but that's how it was defined. Cannot maybe even find that back. To less multiplication is defined as always false except when, and now we're not going to find that exception, right? Constant, nope. Power, nope. Product, yes. But oh, actually, this is the one then. We are going to find it. So the non-product level is that it is not a constant, not a symbol, not a power, and not a product. AKA my multiplication class is not a non-product level type. Therefore, this specialization would be used. Where E3 is the my multiplication and then the other one is product. And that's true, aka it is considered less. So we take this branch here, then we call make multiplication with the product here and the multiplication second. which is actually the type of multiply unequals with not a product, which means this one. Unless we have specializations for that one. I don't think so. Nope. So E1 is a product and E2 is the multiplication. Now E1 is a product, so it's not 0, it's not 1, it's not a constant. Ah, okay. So we actually create a multiplication, which is wrong. How to fix this? Yeah, you know, you can keep adding exceptions. I mean, I can just add the exception for this specific case. But of course, I want to find the most general thing. The most general thing is that E1 and E2 both have a constant in it. And then I want to combine the constant. But even better, actually, is that if E1 does not have a constant, but E2 has it, and I still want to move the constant from E2 into E1. Because I want constants to be, you know, as far as possible to the left. So we should never do this where E2 contains a constant. That's kind of the gist of it, I think. Yeah. I could do, if E2 does not contain a constant, then I do this. So I need something to extract a constant. I removed both. Oh, I have that. I've done that before somewhere else. Yeah. So what do you do is we get this, and then I do these standard checks because, well, if it is 0, then we just return 0, obviously. And if we multiply with 1, then we don't multiply with it at all. Although that should actually be applied on the combined constants. I might as well, you know, extract the constants from both vectors, combine those constants, and then do the check on the constants. Well, this is a special case where E1 is the constant one. Okay, it's a little bit different. A little bit different. I could keep this one. So after this, we get, I should start with extracting constants, I think, from both. Now I have to find back the code that I used before for inspiration of to steal from. How can I find that back? It's something like get constant. What do you think? Get constant. Hey, ta-da! Get constant factor. Let's see, find an add, not very useful in multiply. So get constant factor always returns 1 unless it is a product that begins with a constant. Then that constant is returned. And that's all there is to it. And we can extend that. Have to extend that probably even. So let's move this to away from add to the traits, expression traits. It's hardly a trait anymore, but well. Also have the get non-constant factor. We kind of keep them together, I suppose. Let's put this at the bottom. And Shyful, what the fuck, dude? Gonna kick you out before you. It's I don't know. I'm gonna decide that Shyful is a bot because even if you are doing this without knowing, it's been like a year that you say scalar 3 and amounts and really like you're talking about trying to do something with money, and it's just right, fuck, dude. Fix yourself. Get constant factor. There should be no constant factor in E2. Let's assume that. So this is just recursively getting it from E1, I suppose. Get constant factor E1. Boop, 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 boop. And then we have here, get a non-constant factor for, well, by default, that is just E. Unless it is a product that starts with a constant. What about the constant itself? Oh, that would also works. If e is just a constant, then we get that constant. If it is a product that begins with a constant, then it might be different from 1. No, wait a minute. The non-constant factor. Actually, there is no non-constant factor for a constant. Because we have to take care or not to call that on a constant. And then yeah, then we need one for the product. What did I say? For the multiplication. Multiplication. Which then cannot start with a constant because I have no clue where. Well, actually, if I say that it could be a product or it's either product or not a multiplication. No. What? Oh shit. Life isn't that simple. A second ago I said E2 cannot contain a constant factor, but E1 is not allowed to be a multiplication. It is probably also a non-multiplication times a multiplication. Just like the product. I'm not sure though. Slowly growing over my head again. This will always work, won't it? Multiply. Although I doubt that the whole multiply is necessary. No. What? Wait a minute. That's nonsense. I doubt that again non-constant factor is necessary. Basically, I expect E2 to be equal to itself. But yeah, I don't know. Just do it like this. Just that. By forward. Multiply underscore t does not name a type. Well, it does. So what is its problem? Oh, that's the very first time I use multiply. in this whole expression traits thingy. Yeah, and that thing includes expression traits of age for these. Ooh, that's just problematic. Or not. I can just repeat it at the bottom then. Yeah, it's still not combining it, but it compiled. So now we can fix that one, which was in, I think, multiplied at h. Fix me, yeah. So now I have now I can extract constant factors using constant factor 1 is get constant factor e1. I want to have a look at where I did that before though. There was an add, right? Add.h. Yeah. Probably need all of these. Constant factor 1, get constant e1, non-constant factor 1, constant factor for 2, and non-constant 2. Constant factor is then add, but in this case we need multiply. Multiply to both factors. There is no reason I would do this. I don't know why I did that, but can change it back to add t. And then here we check for trivial constants. And then we do a product of the constant factor to a testing constant factor itself. See, that's cool. Product between constant factor and a non-constant factor 1. Why would that be? Okay, let's not look at this too much because it's computing. Let's do it here. So might as well delay this. I think it might compile slightly faster. Okay, let's begin with the easy case. If the constant factor is 0, that should never happen. That should never happen. Why is that impossible? Because, well, we already tested that E1 is 0. It's impossible that E1 is not 0 but contains a 0 factor, because that would immediately implode to 0. Same actually for E2. And E1 must be less than E2. So either this is a constant and that is 0, or this is not never 0. But if they're both constants, so we will never get here, because that will be a product, I think, or I don't know. It's just impossible. The constant factor is not 0. But let's add a static assert, because I'm only 99% certain. But constant factor can easily be 1, of course. And in that case, I just want to return the multiplication of the non-constant factors. Just throw out the whole constant factor, the whole constant. And if it is not if it's not 1, then I think I just want to have a multiplication between the non-constant factor here and a product with the constant with a non-constant factor there. Which would be correct unless this product is not allowed. That probably the requires of the product itself is going to complain. Let's have a look. It allows E1 to be a constant, but only if then only if it's non-zero. Yeah, but that's not what we're looking for. And okay, restart my sentence. It allows E1 to be a constant, but E2 cannot be a constant. E2 must be a symbol, a power, or a product. So that means that this must be a symbol, a power of a symbol or a product. What would that be? It's not what it could be. It could be multiplication as well. It could be anything. No, I can automate that. Sorry, that's doing double work. So instead of choosing the product, I'm just doing the more general multiply, which will do all that hard work for me. But yeah, then I'm still not happy, because I think that multiplication can only have a non-multiplication as first argument. So it kind of depends on what this is, or not. Suppose this is a multiplication. Do I have that restriction somewhere? Not here. Let's see. Not at all. It should be. Well, like literally inside make a multiplication. So I think if anything is it making sure that multiplication never starts with a multiplication, then it's this function. So you probably have to take care. Yeah, I have to make sure that it's just not that is the case, I think. So in theory, I want to multiply now three things. Constant factor, because that's not 1. And this factor and that factor. And I want to combine these two if that is not a multiplication. But then it has to be a product. So I think I should do... If it is a multiplication, it's kind of the sorting is necessary here. Wait a minute, man. Can do another multiply. I don't want to recursively get here and start all over again. Yeah, I think I just have to try it. Try as in... That's a product, then we can do this. So the new factor 1 just includes both constants. But if it is not a product, then I bet it's actually a multiplication. What else can it be, right? After multiplying and then not being a product. Multiplying with a constant factor and not being a product. That's only possible when you multiply it with a constant, but this is definitely not a constant. So in that case, I think we need a multiplication with the constant and a second multiplication with the non-constant factors. Instance. Set a constival auto multiply on equals expected nested Name specifier. Oh yeah. In substitution of template class E requires expression E using get non-constant factor T. Is type name get non-constant factor type with E is constant 5. Well, that would be... It's not allowed. I added that requirement, you know, so we don't accidentally try to get a non-constant factor from a constant. So it is going to say that it can't find it. Required. Template constraint failure requires not a constant. So why did we require it then? Required from static conceval auto multiply on equals. E1, E2 not a product. With E1 is a constant, that is the constant. Oh, yeah. Yeah, I'm taking that, I'm calling that regardless. So if that's constant, then I'm trying to get that. Okay. Let's rethink that. So if E1 is a constant, then what do I want this thing to be? Nothing, I guess. So again, I think it's impossible that E2 is a constant. So we can always do this. But maybe I have to make an exception for when E2 is literally a constant. In that case, you can't do this. Okay, that's kind of annoying. I have to duplicate everything, I'm afraid. I don't see another way. Well, everything except the first line, so until this point maybe, yes. I can't calculate that one yet. Constant factor, I can calculate that. So delay this one. And then we do if const expression is constant E1, then we do something else. Otherwise I can do this and the rest. And then we have a special case for here. In this case we don't have a non-constant factor because E1 is a constant. Which means that, is it on 1? No, it cannot be 1, because constant factor is now the multiplication of a literal constant with something that might have a constant factor. Actually can still be 1. Yep. Okay. Let's copy everything, paste it in. If it is that, but we don't have this anymore, so now it's not multiplication. Let's just return that thing. Yep. Otherwise, the new factor. Well, I don't have a non-constant factor 1. So really the new factor is the constant factor then? Which is then definitely not a product. So we want to return constant factor with... This is kind of nonsense, or no? No, it's not. Okay, so this becomes again non-constant factor 2. New factor 1 finished. Is it correct? If E1 is a constant, then it is now contained inside constant 1, constant factor I mean. Therefore, we just return the multiplication between that one and the non-constant factor of argument 2. Or if the constant factor is 1, literally that thing, yeah, looks good. Except that it doesn't compile, but that's a minor thing. Struct get non-constant factor from multiplication product constant minus 7. Acquired by substitution, acquired from static const eval. Multiplying equals, so I'm going to skip the requires until we get to the error. Template constraint failure. That's a struct. Should have used the underscore thing here. Underscore T. Better did that in a lot of wordplays as well. Let's look for get non-constant factor being used. It is a struct, is it defined, here it is again a struct and again, oh well, that was the only thing. The only thing. It's still not compiling, but no. Multiply unequals. With E1 is a constant. We are back where we were before. That thing. Required. Error, template constraint failure. Using multiply T. Type, constant factor. Constraint not satisfied. Why are these errors so unclear? Oh, again here. So there's still one left then. There's an underscore T missing here. I'm not gonna read this. Should be able to find that. That one. Yeah. Underscore T. That was it. Never be afraid of a pages long errors. It's always a tiny little thing. Okay, we have this. I have to run the test again. This thing still fails, of course. Of course. Oh, what is going on here? Now it's minus. Oh. No. How did that happen? That has to do with the combining of the constants, maybe. And then a complete failure. So we're trying to combine the -2 and the 5 here. And while fixing that, I broke this again. The one test before that. Because now the minus here is not getting through. The negation is not getting through apparently. Everything before that worked. Yeah, okay, but most of those things had nothing to do with multiplication. That's what I changed. I think the problem is that I have a multiplication, which I only have when I do something with difficult stuff, like an exponentiation multiplied with something. And then the negation doesn't work anymore. So you can make the test a little bit smaller. Let's begin with creating a multiplication. Say y times, yeah, y times x plus y to the power. So that's a multiplication. And then might even be a multiplication if I make this a constant, which would be nice, I suppose. Use -1/2. Let's print that. The out DC. Notice formula. Actually, I want to see the whole type. I want it to compile. What? Unresolved overloaded function. Oh, I did. Never mind. That's only the 133rd time that I made this error here. It's a function. So formula is has completely lost its constant. That's something very serious. Oops. Edit. Okay, so blah 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 blah, formula 1. That is my exponentiation. And now we make a formula 2, which multiplies that exponentiation with a constant. Printing both. So, record them already, because I have not passed the correct string there. And this, of course, should be -1/2 times that. Yep. And then we are going to debug compile time stuff again. The problem is there's multiplication here, so we do not want any other multiplications. My thoughts are don't worry about it. Not anytime soon. Okay, so multiplication. Operators. Operator star. Yeah, just to as a warm up. Static assert. Dependent false on something you want. We get here. And then we see that we get here from... Where's my test suit? What? So it's not printing the... It is not... Is it not printing the line, or is it just completely fucked up here? It's like I'm missing a new line. I saw that before, but maybe we miss more. Actually, oh god, I saw a we get here, but that was not a we get here that I wanted to see. Okay, so we get here, and then well from that point. Nah, I'm working on test suit, dude. Don't give me what get here's for unrelated stuff. Symbolic test suit. Yeah, without a CXX. Finally, okay, so we get here from Formula 2. Yay, so Formula 1 doesn't multiply. So this star here is indeed ending up here. Yeah, this operator. But yeah, I knew that. Which then goes to multiply underscore t, which is obviously just one thing, this, which is done to multiply. And then the question is which multiply? Well, not this one, because that's a constant. What am I multiplying? I am multiplying with a constant. Oh, well, this is multiplying constant with a constant, so not this one. Next. That's a product, it cannot also not be. E2 is multiplication. So, oops, this one. Yep. This one. Actually, it's not a multiplication, it's an exponentiation, which would be this one. So, I think we get here. Bing. Static assertion field we get here. Quiet from here. And I'm doing it again. Yep, okay, so again, from that point, formula 2, we get here. Okay, so most notably, we do not, for example, get here. Yes, that's a different function. We don't get that. Oh. No, I don't get that. So that worked. So we get here, and then what happens? I'm pretty sure that the first thing, the constant is less, so we should get here. And we do. And that calls make a multiplication, which calls multiply on equals with a not product, which is this one. So we get here. Let's just do the assert here and then see what the again what E1 and E2 are. As if the compiler wanted to print it. Oh, it does print it. There's some more this time. E1 is a constant minus a half, yes, and E2 is an exponent, exponentiation. Perfect. Exactly like the doctor ordered. So is constant 0? No, it's minus a half. Is constant 1? No, it's minus a half. So we get here, right? Yes. Is a constant? Yes. So we should get here. There we do. Is it 1? No. So we do this. Apparently. No, we don't. So the constant factor is considered to be 1. Okay, that's shocking. We are not getting here. But we are getting here. So this is the problem here, right? Maybe it's time to print constant factor for a start. It's not printing constant factor. It just says constant factor without printing it. Well, then I have a runtime thing that prints types, but how do you make a compiler print a type compiler? It must be possible. It's printing it all over the place. It's a good start. Oh. For some reason I don't see a we get here at all now. Oh yeah, show me the constants. Candidate. Expect one argument you are provided. Okay. Stupidity. Stupidity. It's just not printing it. It's just like really. Oh, here it is. And show me the target with t is constant. Yep. Okay. Constant 1. Oh, the constant is 1. Well, that explains it. So then it says, is it 1? Yes, return that. So, but why is it 1 then? Because I'm multiplying constant factor 1 with constant factor 2, and I would think that constant factor 2 is 1, and constant factor 1 is minus a half. So multiplying that should give me minus a half, obviously. So which one is wrong then? So that prints 1. And I would think that that is minus a half. Nope, it's 1. It's 1, 1, 1, 1, 1. Okay. Therefore, the problem is that get constant factor returns for a constant returns 1. Oh, 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 huh? What? No. Tick. No, well, once again, the get constant factor returns 1. Yes, unless you overload it. So apparently I did not overload. I did not specialize it for a constant. That's the answer. Yeah, I only specialize it for a product. It's just... I guess I didn't need it before for the product. But now we do. Get constant factor specialized for a constant is that constant. No, it works. It's minus a half. Enable the whole test again. Including the last two tests. Now it's calling a get non-constant factor again on a constant. I thought I stopped that. Quite from get non-constant factor multiplication constant. Oh yeah. Yeah, yep. It's just not that easy, is it? If in this case, if E1 is a constant, then this fails. So you have to make this a little bit difficult, different, a little bit harder, a little bit more sophisticated. Where's my default stuff? It's just not here, right? I can't read this either. It's scrolling too fast, but I was looking for something. Yeah, it is defined in multiply. Expression traits, multiply, expression traits. It works. And we have our -10. It has combined it. Yay. Took only a few hours, or how long, I don't know. How much stream? I'm streaming 4 hours. That is bedtime as well, yeah. I had one more test though. Shortest length 2. No, it's -10. Yeah, that was the same test, I think. But now it's calculated as a derivative. So the derivative of 1 minus x squared to the power of 5, partial derivative relative to x, is -10 times x times 1 minus x squared to the power of 4. Just so you know. Compile time derivative. I think this is a brilliant moment to stop, because all those derivatives now work. And now I'm gonna go to bed. Good night, everyone. Thank you for watching. I have all warm feelings because of you are here. And all the best. I'm going to bed. I'm not going to sleep. No. I woke up at 11 in the morning because my alarm went off. So I had to get out of bed and stop the alarm, and then I went back to bed, of course, and I fell asleep again. I don't know how long I slept, but eventually I got out of bed at 4 p.m. So now it is, by the way, 1 a.m. here. So you ask yourself, why is he going to bed? Yeah, I don't know, actually. But I'm going to watch a movie. In bed. Luxury.